Hello everyone, welcome to week 3 for Algebra 1B. We're going to be getting into exponents and exponent properties. So for week 3, make sure you're following along with your textbook. I go through sections 1 through 5 for week 3. Take notes, use this video to help you do the practice problems, the paper pencil problems, and the quiz for the week. So here's what we're going to be learning for week 3. I want you to be able to rewrite algebraic expressions using exponent properties. We're going to do that a lot today, talk about what properties these are. If I give you an algebraic expression, can you recognize and use the product, the power of a power property, or the quotient properties correctly? If I give you a fraction, can you understand how to apply exponents to the fraction correctly? If you're given a negative exponent, can you explain how it is the opposite of a positive exponent? And finally, if I give you a fraction exponent, can you explain how it is the same as a radical of the nth power? So we've got lots of stuff to kind of cover as we start digging into exponents. Up to this point in algebra, we've only been focusing on linear functions. The rest of the semester is going to be spent looking at exponent and quadratic functions. So we're going to get into nonlinear things. And if you want a really quick summary, linear involves a pattern where you add the same number over and over again, repeatedly, which we call the slope, so they always grow at a nice straight line. Exponential functions involve patterns where you multiply by the same number repeatedly. We're going to look a lot at exponential equations, exponential graphs, exponential patterns. Quadratic functions involve growth where you have x squared. So you have some variable squared, and you see how that affects the graph, the tables, as we work with different types of problems. So you go, that's what we got coming up. We're really digging into exponential patterns, and you spend the next few weeks looking at exponential type equations, graphs, and functions. Before we can really dig into exponential functions, however, we really need to learn some new algebra skills. So this week may be kind of on the boring edge, but we have to learn how to work with exponents, what exponent is, before we can start really handling some good complex modeling with exponential functions. So here we go, an exponent. Some of this may be review, but just kind of hang on there with me. But an exponent is simply a notation for repeated multiplication. It all comes down to understanding that 3 to the 5th power, again 3 is our base number. This 5 here is our exponent. And all that is telling you is 3 to the 5th power means I have 5 3's all multiplied together. So 3 to the 5th is the same as 3 times 3 times 3 times 3 times 3. And if you do all that, I believe it's what, 9 times 9 is 81. Is that 243? I'll do it, just check it on my computer as well here too. So 9 times 3, 243, yep. We're going to, as we deal with exponent properties and we start simplifying complex algebraic expressions, we're going to come back to what we call putting it in expanded form, thinking about what do the exponents mean. So that's expanded form right there. Okay, let's start with the product property. When multiplying exponential expressions with the same base, we can add the exponents together. Let's think about this. We have t to the 4th times t to the 3rd. What does that mean? What is that going to end up equaling? Well, t to the 4th means we have 4 t's multiplied, right? Times, so there's 4 t's, times t to the 3rd. That's 3 more t's. Well, how many t's do we have multiplied together? 1, 2, 3, 4, 5, 6, 7. There are 7 t's all multiplied together. And you can see how we add the exponents. 4 t's multiplied by 3 more t's equals 7 t's all multiplied together. So we can add the exponents if you have the same base. That is the product property. It's the first one we're going to get into. In general, the product says if you have any base to some power times the same base to any other power, we can rewrite it as one base, the same base, but to the m plus n power. We can add the exponents. The quotient property is really similar. When I divide by the same base, we can subtract them. So let's look at what we got here. We have x to the 8th, that's 8 x's. X times x times x times x times x times x, that's what, 6, 7, 8 x's all multiplied together, divided by x squared is 2 x's on the bottom. Well, one thing we notice is when any number divides by itself, if I have x divided by x, that's going to divide each other out and end up turning into just 1. 1 over 1 or just 1. So we look for, I can't change color, that's a bummer. So when we look at simplifying this x up here divides out with 1x up there to make 1 over 1. Another x on the top divides out with an x on the bottom to leave 1 over 1. And so we see we end up with 1, 2, 3, 4, 5, 6 x's on top divided by 1, or just 6 x's. So x to the 8th over x squared equals x to the 8 minus 2, subtract the exponents, which just equals x to the 6. It means there's 6 x's once you divide out a certain number of x's on the top and the bottom. We can see that right there with the 1, 2, 3, 4, 5, 6. So if we're dividing and they're the same base, we can subtract the exponents. And in general, there's the summary of the quotient property. Any base b to the m power divided by the same base b to the nth power equals b to the m minus n power. Finally, there's a power of a power property. This one, I'm going to change colors, got sick of red there for a little bit. Let's turn to blue. This one says I have a to the 3rd all to the 5th power. Let's write that out in expanded form. So we have a to the 3rd, which is a times a times a. But I have 5 of them, right? So there's times another a times a times a. There's 2 of them times another a times a times a times another a times a times a times one more a times a times a. And you can really see when I have a to the 3rd all to the 5th power, that's 1, 2, 3, 4, 5 groups of 3a's. 5 groups of 3, that's multiplication. So it ends up equaling a to the 15th power. So the power of a power property says if you have 2 exponents going on, we can multiply them together. 3 times 5 would be 15 a's altogether. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There is the power of a power property in summary. B, any base b to one power and another power, you end up multiplying the exponents. Okay, so what do we do with a negative exponent? How do we work with negatives? Well, negatives, we know a negative sign means the opposite, right? If you have plus 3, the opposite is plus negative 3, which is subtraction. It kind of works the same way with exponents as well. M to the positive 3 power means m times m times m, right? It means we multiply 3 m's together. I could even think about it as 1 times m times n times n. That's m third. Well, the opposite of multiplying is division. So when you have a negative, it tells you how many m's we're dividing by. So we still start with a placeholder of 1, just like up there. But instead of multiplying by 3 m's, I'm going to divide by 3 m's. So I divide by 1, 2, 3 m's. And so it equals 1 divided by m to the 3rd. Whereas up here, it's just 1 times m to the 3rd, or m to the 3rd. So when we have negative exponents, it's not subtraction. It's not even multiplying by -3. It's not even a negative number, other than it's telling you the opposite of multiplying m times itself 3 times is to divide by m by itself 3 times. So here we go. If you have a negative exponent, we can rewrite it as dividing with a positive exponent. And if I have a negative exponent in the denominator, I can rewrite it as a positive exponent in the numerator. That's how you work with negative exponents. Okay, so let's summarize. We got the product property, where you can add the exponents. We got the quotient property, we subtract the exponents. We have the power of a power property, we multiply the exponents. And you have negative exponents, which are the opposite, which means you got some division involved. Hopefully you have all these written down in your notes with some examples. There's some great ones in your textbook as well. But the next step is then to put all of these properties to use and start to be able to simplify and work and rearrange all sorts of algebraic expressions that involve exponents. Okay, so let's start with this one. I have 2 times a to the third times 5ab squared all to the third power, and I want to simplify it down as much as possible. Simplifying means I want to reduce any fractions. It means I do not want any repeating variables. So here I've got a there and an a there. I just want to have one variable of a when I'm all done. And I don't want any negative exponents. So everything needs to be a nice positive exponent when it's all done. Okay, so let's see what we start with. I'm going to look first at this exponent of 3, and I know I'm going to use the power of a power rule. Everything inside gets the third power. So I still have 2a to the third, but it's multiplying 5 to the third. That gets the third power. A also gets the third power. I'm going to kind of write it in expanded form and include all the multiplication. And this b squared gets the third power. But what's funny is it's already b squared, so we need to use the power of a power rule. B squared to the third power, that's going to be b to the 6th, because I multiply my exponents together. So that's what I did for the first step. Is I just took this exponent of 3 in the parentheses here and gave everything inside the third power. All right, let me switch colors and let's now look at anything I can combine here. I have a to the third and I have another a to the third, and they're being multiplied together. Well, the product rule says if I have a to the third, or 3 a's, times another 3 a's, how many a's is that going to be together? That's going to be 6 a's altogether. I can add the exponents. 3 plus 3 gives me 6. I still have my 2, and 5 to the third, that's 5 times 5 times 5, that's going to be 125, times my a's to the 6, and I still have my b to the 6 there. So I've simplified a little bit more. Now let's put it all back together. 2 times 125 is going to be 250 times a to the 6 times b to the 6. And there we go. We've simplified everything out as much as we can. It looks a little bit friendlier, a little bit easier to work with. All right, this one's probably going to involve the quotient property. Got some division, I got a fraction here, and I got some negative numbers to deal with. So let's talk about how to simplify this one out here. I'm going to first write it out in expanded form to help me kind of see. So we've got 3 over 15 times, I got x to the negative 2 over x to the negative 5th times y to the third over y. And I want to see if I can simplify some things down. The first one that really jumps at me is reducing 3 over 15, reducing that down to 1 over 5. For the x's, there's a couple ways I could think about doing this. I do know when I have division, I can subtract the exponents. So this is the same as x to the negative 2 minus negative 5. Be careful with all your negatives, but that turns into negative 2 plus 5, which is going to end up being x to the third. The other way I could do this is to take x to the negative fifth is the same as x to the positive fifth in the numerator. X to the negative 2 in the numerator is the same as dividing by x to the positive 2 in the denominator. And then I can see, well, 5x's on top divided by 2x on the bottom, that also equals x to the third. So either way, it's going to reduce down to x to the third. For my y's, this is really, I got 3 y's on top, but I got 1. Sometimes it's helpful to even write the exponent of 1 on the bottom. That's going to divide out to leave just 2 y's in the numerator. So when I put it all back together, we have x to the third on top times y squared on top, but the 5 was on the bottom. Notice on the denominator there. So it all simplifies into that. The last thing I want to touch on, and you're not going to do a whole lot with it right now, but it's still a useful thing to know, is when we're doing roots, square roots, cube roots, fourth roots, any sort of roots, it's really similar to doing exponents with fractions. For example, if we have, say let's take 4. The square root of 4 is going to be 2, because 2 times 2 is 4. The square root of 9 is going to be 3, because 3 times 3, or 3 squared, gives you 9. So we're going to talk about square roots more eventually, but that's what we have with square roots. I can also think of them as powers. So notice this n right here, this would be considered a square root. That's your index. I can rewrite it as a fraction exponent with n in the denominator. So the square root of 4 would be the same as 4 to the 1/2 power. The square root of 9 would be the same as 9 to the 1/2 power. And you can check this out with your Desmos calculator, but that's just starting to touch a little bit on fraction exponents and how they're similar to square roots, some stuff that we've already been working with. So let's simplify this expression. What do we got going on here? There's a lot of jumbles of a's and b's and exponents, right? Well, let's again just go slowly but surely through the exponent. I'd have a power of a power, so this 1/2 is going to affect everything in the numerator and denominator is going to get the 1/2 power. So I got to use the power of power rule. And then I'm probably going to use the quotient rule for the a's and the quotient rule for the b's. So let's first give everything the 1/2 power. So we have a squared right there, but it also gets the 1/2 power. So I'm going to apply that there, times b to the 1/3, but then it also gets the 1/2 power, all divided by, we have a to the third on the bottom there, but that gets the 1/2 power, times b, and that gets the 1/2 power. So when you have parentheses and an exponent around the parentheses, everything inside gets that exponent. All right, now let's simplify individually some of these exponents and stuff here. So a squared to the 1/2 power, if I multiply, power of a power rule, I can multiply those together. 2 times 1/2 is just going to be 1, so I end up with a to the first power, just a. For this one, b to the 1/3 times 1/2, if I multiply those, I get b to the 1/6 power. So I got a fraction exponent. On the bottom, 3 times 1/2 is going to give me a to the 3/2 power. On the bottom, I've got b to the 1/2 power. There we go. Now let's use our quotient rule. If I think of this as a to the first divided by a to the 3/2, that's going to be a to the 1 minus 3/2. And then with the b's, it's going to be, subtract the exponents, that's going to be b to the 1/6 minus 1/2 power. Well, 1 minus 3/2 is going to be negative 1/2 times b 1/6 minus 1/2. So 1/2 is the same as 3/6. So 1/6 minus 3/6 is going to be b to the negative 2/6. With my negative exponents, I can rewrite them as positive exponents by putting them in the denominator. So that becomes a to the negative 1/2 becomes 1 divided by a to the positive 1/2. It's the opposite of multiplying is dividing. And then my b gets to the, I'm going to change 2/6 into 1/3, simplify it down. And then finally, if I really wanted to, I could change that into 1 over the square root of a times the cube root of b. I could rewrite it into radical form. So you can leave it into fraction form or radical form. I just wanted to kind of see how they were related. But there you go. We simplified that down. There's no repeating variables. There's only 1a and 1b. There's only positive exponents. And we simplified them down as much as possible. All right, that's a little bit about week 3. Using exponent properties, just practicing, get some good practice in this week. It's going to be a little bit weird at first. There's no really 100% one way. There's oftentimes a few different ways you can simplify an expression. We just got to get in and try around. Let me know if you need some help. Make sure you're using some good notes, using your resources, and have a good time this week.